What is a limit? The precise definition of a limit is far too complex to understand because it involves indecipherable mathematical notation using epsilon and delta. The limit of a function is most often a value. Say we have a function f of x, and as x gets closer and closer to c, where c is just a random number, the function itself, f of c, gets closer and closer to L, where L is just a value in the function. Graphically, this is what a limit is. There is a function f of x, and as the values you plug into the function get closer and closer to a, you can see the function is trying to approach L, which is simply a point on the graph. But for a limit to exist, it has to meet some criteria. That means that a function from both the left and the right has to approach the same value. So there's this function 8 over x, and the definition of a limit was that the limit of a function, the limit of f of x as x gets closer to c is L, and c in this case is 2. So if you want to find L, you need to find values closer and closer to 2 but less than 2, and values closer and closer to 2 but greater than 2, and you have to see that they're both approaching the same value. So if you plug in 1.9, which is fairly close to 2, you would get 4.21. You can see as you get closer and closer to 2, taking in values from the left side of 2 and the right side of 2, such as 1.999 or 2.0001, you would get really close to 4. So we can conclude that the limit of 8 over x as x gets closer to 2 is 4. So the limit exists because the left side limit and the right side limit both equal 4. Now, let's take the same graph and say if that point was not defined, that limit would still be 4, because irregardless of the function's continuity at that point, the values are all approaching 4 at x equals 2, or near x equals 2. So the limit would still be 4 even if the point was not defined. Now, it doesn't mean that all functions are defined and continuous everywhere. It also doesn't mean that all functions have limits everywhere. I mean, sure, a limit could exist when there's a hole, but that doesn't mean that the function is continuous. That means that even if there might be a limit of the graph, it doesn't mean that the function itself is continuous. So here are some types of discontinuities that deem a function not continuous even if there may be a limit.
Alright, so I'm here in McDonald's. Where are you at?
I'm on my way. I'll be there soon. Hey, I'm at the McDonald's now. But I don't see your car anywhere.
I'm inside.
Hey, did your mom drop you off or something?
No. My car's outside.
Wait, which McDonald's are you at?
I'm at the defined McDonald's. The one that's near the police department.
Oh, I'm at the one near 77.
Where are you at the McDonald's across from I-77?
Oh shoot, you're right. I'm at the undefined McDonald's. I went to this one because I told you I was in Troutman this weekend working. So I was coming down and figured that this one was a little bit closer.
Just let me know when to start.
Alright, go.
Alright, Alright, go.
Oh yeah.
Go.
I'm on my way. I'll be there soon. Oh, hold on. Let me cut off. Your mom drop you off or something?
Alright.
Hold on. Let me say that again.
Go.
Did your mom drop you off or something? Dang. So I was coming down. Are you kidding me?
Go.
Oh shoot, you're right. I'm at the but I don't see your car anywhere.